Hey, good morning. 2 days this week, today and tomorrow, and then we get to have a vacation here. So today we're going to start working on graphing or solving systems of equations. I can tell by your tests that you turned in that a lot of the people online are not using a ruler and also not watching my videos either, which you're at the point, which I know I'm probably preaching to the wrong crowds, but it is my hope that maybe some people are changing their behaviors and starting to watch the videos. You can't fake your way through math anymore. I was kind of disappointed on about half of you, but again, over half of you aren't watching the videos. That on the review here, you said you did a 38 or a 37, you did really well. And these two questions right here were on the last two quizzes, plus the review, plus the test. Exact same questions about talking about whether they're linear or not. And I'm getting some really crazy, strange answers there. So I know you're not watching the videos, some of you. So if you missed these questions, I want to put the review back up today, and hopefully you'll go back and look at the review closer rather than just saying, hey, I got 36 out of 36, perfect paper, and then you flunked the test. We are coming up on the big unit test or the semester test. Very, very important that we figure this stuff out, that we just don't keep saying, oh yeah, I got a good paper, and then you take the test and you can't do the same work. That's kind of disappointed on this one because this is now worth a 5-point question here about talking about rates of change. And a lot of you are still missing this. Again, it was on the last two quizzes, it was on the review, it's on the test, and it's going to be on the next one. So I'm hoping that you kind of start watching this. So I just want to do one of them on here because it's always, rate of change is always the y's over the x's. That will never change. Y over x, rise over run, slope, same thing, all the same thing. And so I even on the quizzes and the tests even reminded you here to get it down to a unit rate and then show appropriate units. So this problem right here should have looked like this, and this is exactly how it looked on your review answer sheet. But again, some of you said, oh, I did a great paper, Fisher. You're not fooling anybody except for yourself. And you're not even fooling yourself. So I hate to start harp on a Monday morning, but you guys really gotta. So these are my X's. These are my Y's. Age, years. So I have 22, take away 20.3. That is a 1.7 over 30. Unit rate means to get it down to 1. So if I got that down to 1, then I get a 0.06. Now, it says put your appropriate units. Top is my Y's, that's age in years. And then down on the, I want to put age here. You could just put age per year. So every one of these, that means this person here is growing at 0.06. What are my units? This table shows the median age of the women. So they're 0.6 in their age every year. They're increasing at 0.6 between those years. So there should have been a lot of work there. That's why it was worth 5 points. You take 5 points, and that whole test, I think, was worth 36 points, 37. Just getting that one question right would have raised your score 10%, 13%. One whole grade just by getting this one problem correct. Yeah, it's worth a lot of points. Doing better on some of these slope ones here. Finding the slope. Anyhow, somebody kind of mentioned, Mr. Fisher, can I make corrections on the test? Yes, I hope you do make corrections so that on the next test and quiz that we continue getting better, not worse. Okay? All right. Sorry about harping on a Monday morning. And again, I'm probably harping to the wrong crowd. So today, if you would do the warm-ups real quick. I have the answers on the next page. Pause your video, do these real quick, and we'll see how you did. Okay, welcome back. There's two problems that are very, very important today. 2 and 3, because we're going to do this often today. Well, they're all important because slope-intercept form is the fast way to graph. Here's the answers. It's a solution of a linear equation is any ordered pair that makes the equation true. So we plugged a 2 in. We got 24 on that one. Number 3 is very, very important. And again, I'll be able to tell who watches my videos today. When you say, yes, I do all the math and I get 13 equals 13, we call that a solution. Okay, so yes, it's a solution. How come? When I substitute the coordinates into the equation is true. That is a perfect way to explain how you know it's a solution. All right, and then getting this one into the slope-intercept form, there's all my work. Y equals a negative 2/3 x plus 2. All right, so today we're going to have to start writing our own equations. They're not going to help us as much. And so here's talking about two bowling companies that had charged different amounts. And Bowl-O-Rama charges $2.50 per game plus $2 per shoe rental. Well, Bowling Pins charges $2 per game and $4 for shoe rental. So one charges more for shoe rentals but less per game, and the other one charges more per game but less per shoe rental. And so these are what we call systems of equations because we have two equations, and this happens all the time in real life. Cable companies, cell phone plans, they all have different rates that they charge you up front and then per month, and they try to keep you kind of changing the game all the time to keep you a little bit confused because they know most people won't do the math. And so be a wise consumer. It's not hard. Just do the math and then figure out which one's the best deal. So a system of linear equations is a set of two or more linear equations containing two or more variables. I was just helping my Algebra 2. They get 3 equations with 3 variables on theirs. That was kind of a challenge. I was helping some kids after school last Friday. A solution of a system of linear equations with 2 variables is an ordered pair, very important, that satisfies each equation in the system. So if an ordered pair is a solution, it'll make both equations true. So here's my ordered pair, just like we did in the warm-up. This is my x, this is my y. Let's plug them into the first equation and see if it equals 6. Oops, I don't want to write x, I want to write a 4. You must show your work. Please don't just say, I did it on a calculator. It's not hard work. Right now, they're very easy ones. Soon we will get decimals. So practice showing your work. I get 6 equals 6. I usually put a check mark saying, yes, it works. Then over here, we want to say 4, that's my x value. There's a minus in the equation, 1. Does that really equal 3? Yes, it does. So this is a solution. It has to work in both equations in order for it to be a solution. All right, let's go over and do this one now. Here's my x. Some people still do this, and y. Does that all equal 8? So that one equals 8. Make sure I did everything right. I think so. So I got a minus 3, minus 4. That's a minus 7 equals 5. That is not true, so not a solution. And so you'll see today, sometimes we'll think we have the answer. We'll plug it in and check, and it's not working. All right, so here's 2 for you to do. Do these 2, practice. With practice, you'll get faster and accurate, so just don't skip it. I know you want it to be over with today's math, but the practice is where we get faster and better at our math. Okay, let's see how you did. I got a solution for the first one and not a solution for the second one. Okay, here was my work. Now, All solutions of linear equations are on its graph. To find a solution of a system of linear equations, you need a point that each line has in common. In other words, you need their point of intersection. Where they cross, that's going to be our solution. So in this case, the two lines cross at 2, 3, the coordinate 2, 3, and that is the solution. So then we would go ahead and check our work. Okay, now graphing very quickly. Some of us are still not graphing. -1 is my y-intercept, so they put a dot at -1. My slope is a 2, so that means go up 2 over 1. 1, 2 over 1. 1, 2 over 1. And there's my graph. Now, if I go to my orange graph or red graph, 5 is my y-intercept right there, and it's a negative slope, down 1 over 1, down 1 over 1. Draw my line, very accurate with a ruler. Okay? So graphing, now we should be very quick at, especially when it's in the y equals mx plus b form. So let's graph this one real quick. I know it's a y-intercept of -3, and my slope is up 1 over 1. Draw your line. Again, I have some pretty crazy graphs. Kids freehanding it on the test there. Okay, there's my first equation. -1, and I have a -1. Now notice something here. When I went down 1 over 1, I hit the same dot, so I'm pretty sure that's going to be my solution there. So I'm just going to come down here and write that. It's 1, -2. Written as a coordinate. Okay. Let's go ahead and graph it though. Alright, so there's my graph. Again, very nice and neat. Now let's check our answer. We think it's 1, -2. So the way we check it is you don't have to rewrite the equation, just put the numbers in the right place. And again, it goes very fast. Works in the first one. There's a minus in the equation, so it's a -1, -1. I get a -2 equals a -2. So I know that that's the solution, 1, -2. Let's go over and graph this one. Uh-oh, my graph kind of overcovered my number there. I think it's a 2. All right, now this one here is in standard form, so my x-intercept and my y-intercept is 0. So I know it's going to go through my origin. Now I want to get that into the y equals mx plus b form though. I want to work my way up, because it's only a one-step equation, so it's a minus x plus 0. So there's my y-intercept, 0. It's a negative slope of 1, up 1 over 1 to the left. So let's graph that one. Again, figuring out ways that you're going to get it graphed quickly and most precise, accurately. All right. Got a 1, I go down 1 over 2, or I can go up 1 over 2, and look at that, it lands right there. So I'm thinking this is probably going to be my intersection. I want to go down 1 over 2, down 1 over 2. The more dots you get, the more accurate your graph is. But I am thinking that my answer is right there where my circle is. So sometimes we'll kind of do that. We'll just do the slope until our two intersect. Again, we'll get a more accurate answer. So I'm thinking the answer is -2 plus 2. -2, 2. All right, let's check it out and see if it works. Zero equals 0. It works in the first equation. Negative times a negative is a positive. 2 divided by 2 is 1. So 1 plus 1, 2 equals 2. So it works. So I know that is the correct answer. All right. You give it a try now. Here's 2 for you. And again, I have the answers on the next page. So if you just pause it and draw your lines, see how you did. Okay. there's my answers, and there I am down there checking my answers. So this is where some kids that are really worried about their grade can increase their score. They should be getting really, really high scores, because if you check your numbers, they should work. If they don't work, well, then probably the slope on your graph is wrong or something along those lines. That's usually the biggest mistake kids make, is they didn't graph it correctly. I'm hoping on 2B, you notice over here it's in standard form. And so I hope to use the x-y intercepts. My y-intercept was 4. My x-intercept, if I put a 0 in for the y, we got 2x equals 4, which would be a 2. So again, using all those strategies to help us graph quickly and accurately. Now we're going to leave it up to you as to how you get it on that graph paper. T-charts will always work, and actually we're probably going to have to use a T-chart down here on some of these guys, okay? Because word problems are kind of tough, especially if you get into money and things like that. Here's our Bowl-O-Rama. They charge $2.50 a game plus $2 shoe rental, so a one-time rental fee. And the bowling pins charges $2 per game plus $4. How many games will it cost to bowl to be the same in both places? What is that cost? The answer will be numbers of games played, which is the total cost is the same as bowling alleys. So list the important information. Let's make some equations here for Bowl-O-Rama. We know that we paid $2 only one time for their shoes. And then I play $2.50 for every game. So if I bowled 2 games, I owe $5. If I bowled 3, I'd owe $7.50. And so what are we doing? We're taking $2.50 times the number of games I play. So already right now I'm thinking on my x-axis it's going to be numbers of games. And then my y-axis is going to be my total cost. That's an L. Okay, let's go over to bowling pins. Bowling pins says they charge $4 for shoe rental, but they only charge $2 per game. Now, I can do 2.5 over 1 is my slope and 2 is 1. But even that we're going to find is a little bit tough down here. All right, so what I did is, so that we can get to the graph here, I wrote the same equations. Pretty sure they're the same. Yeah. 2 and 2.00 is the same. Okay, so what did we say up here was going to be on our x-axis? Our number of games. Okay, and then over here on the y-axis is going to be our cost. And I'll leave some room for your numbers here. Now we have to make some kind of a scale. So when we get to decimals and fractions like this, sometimes it's a little harder to decide on what we're going to do. I know the number of games is not going to be that many. You're not going to bowl 20 games, so I'm just going to kind of guess some schedule here, and I'm going to make every other one a 1. So I'm going to count by halves here, because even 6 games would be a lot of games to bowl. Now moving up this way, I want to just maybe say, well, if I counted by ones, 1, 2, there's like 20 lines there, so $20 would be my cost there. Yeah, let's try counting by ones. So I'm just going to list every other one and just see how this works. 2, 3, 1, 2, 3, 4, 5, 6. Sometimes we have to erase our scale here. So let's just kind of see how it works out. All right, so my y-intercept is a 2 on that first one, so I know it's going to cross the y-axis at 2, but it's kind of hard for me to go up 2.5 over 1, but I could go, if it's, I want to do this, if it's 2.5 over 1, that would be the same as go up 5 over 2. Even that's kind of, well, no, that might be okay, because we're counting by ones. So if I go up 5, There's 1, 2, 3, 4, 5. Now we're counting by over 2 would be like right there. So let's try that and just see how it works. I got to do my own graph, which is a lot of planning, and sometimes my planning doesn't go like I hope it does. So they take a little bit longer. All right, let's just try that and see how we come out here. All right, my next one has a y-intercept of 4, and it's up to 1, 2 over 1. Now again, make sure, because we're counting, up 2 over 1. Up 2 over 1. I'm almost thinking I see my answer there. Maybe not. Let's try drawing it. This is where things get a little frustrating for sometimes if we're not graphing right. Okay, so now you see how mine's kind of like right smack dab in the middle of nowhere where they cross? I'm thinking it might be this one right here called 412. So let's try it. This is where checking your work is very important. So I'm thinking it might be 412. So let's put it here as a coordinate 412 so we don't forget. So my y value is 12 equals 2.5 times 4 plus 2. That would be 10. Hey, did we get lucky or what? So first one it works, 12 equals 12. Okay, let's try it in the second one. 12 equals 2, nope, times 4 plus 4, that's 8 plus 4, 12 equals 12. Nice. So it works in the second one as well. So now I have to word problems. Again, my online kids, I know you're not watching my videos because all word problems have to have word answers. We just can't say 412. We have to put some meaning to this. This is my x, this is my y. 4 is my x, 12 is my y. So x is the number of games. So in 4 games, the cost will be the same. The cost will be $12. This is the right answer. This is what we're striving for. The coordinate 412 means nothing to somebody on a word problem. Okay? So make sure you kind of explain your answer in words. All word problems need word answers. So that's what, if I was grading your paper, I'd be writing on there and you'd get half off. All right, so here's a video club. They charge $10 for a membership fee and $3 per movie. Notice they're not writing the equations for us anymore. Video Club B charges $15 for membership and $2 per movie rental. So try writing the equations real quick. It's very similar to the very first one. Let's make sure we get the equation right. Club A and Club B. So Club A, they charge a membership fee, so you only pay it one time. Kind of think of it that way, because the y-intercept is a little bit easier. And then you charge $3 per movie. Sometimes we'll start using numbers or letters like that. That M is the number of movies I rent. So you can write it 3.00 if you want, or just 3M. Okay, same thing. I just know it's money. The next one, they charge $15 up front, but they only charge $2 per movie. So that equation, I hope you had y equals 2m plus 15. So movies has to go down here, number of movies. And I would probably do the same thing as we did up above, count every other one as 1. And over here, we're back to cost again. Okay. All right, so I got the answer on the next one. Now be careful when graphing this one because this one's kind of really a challenge to get the answer the right time. If you get it the right time, you are awesome. Okay. All right, so here's what I got. I had to guess. I was wrong on the first one. I was thinking it was 524 because if I went up 5, it's kind of like right there at 24. And then I says, well, that one's off. So then I bumped it up to 525 and I got the answer right. So first guess was incorrect. My graph was not quite accurate enough, but I came close. So final answer is the cost will be the same for 5 movie rentals and the cost will be $25. Okay, that's when they're both the same. Pretty soon here, they're going to start asking you questions like this. Well, which company, if you were only going to rent 3 movies, which company would be the best one? Well, whichever that purple one is, which this is now how we start writing equations on there. Let's see, it had a y-intercept of 10, so I'd be on Video Club A. And if I rented a lot of movies, well, then I want to go with Video Club B because after 5 movies, B is a cheaper one. So then we can start making some wise choices about how much, which one we want to sign up with. All right, with that, you need to just do this practice sheet, put your answers in, make sure when you do your solutions, I don't know if this is a solution or not, it probably is not, that would be a very good guess, that when you put your answers in, that's what I'm going to look for. If it was a 2 minus 3, you have parentheses, 2, comma, -3, close your parentheses. I'm looking for the solutions on your input today on the Google form. All right, with that said, tomorrow we're going to do the same thing, so there won't be a video tomorrow, it'll be just a practice sheet. And I want to give the kids the whole period so that they hopefully don't have any work hanging over them over the Thanksgiving break. All right. Well, have a good day, and we'll see you after Thanksgiving break.